Hello everyone, how are you? In today's lecture we are going to discuss a new chapter, that is flavonoids. So before I start with flavonoids, I'll go through the learning outcome of the whole chapter, and I would like to mention that this chapter flavonoid will be discussed in multiple lectures, probably 3 to 4 lectures. So first I will go through the learning outcome of the whole chapter. So at the end of this lesson, okay, that means the whole chapter of flavonoid, you will be able to define flavonoids. You will be also able to explain the chemistry of flavonoids and classification of flavonoids, and also you will be able to outline various examples of different classes of flavonoids, and then you will be able to describe the biosynthesis, extraction and isolation process of flavonoids, outline the significance of flavonoids. Significance means what are their roles in nature, to the plant and also to the human body. Then you will be also able to explain or outline the natural distribution of flavonoids that are present, like which are the different fruits or vegetables that contain different types of flavonoids. Then you will be able to explain the mechanism of action of certain flavonoids. Even though flavonoids are involved in different biological actions, we will be mainly discussing the important mechanisms of action that are already established. Okay. Then we will take the examples of few flavonoids and explain the botanical name, outline the botanical name, family name, and explain the medicinal uses of rutin, hesperidin, genistein and diaziin. So first we will start with the introduction of flavonoid. What are they? Let us see. So flavonoids represents a diverse class of naturally occurring polyphenolic secondary metabolites. Diverse class means they are structurally different in nature. Even though they have the same basic skeleton, they are classified into different class. We will be going through one by one, and all of them have more than one phenolic group in their structure. So they are polyphenolic in nature, and they are found either in free form or as glycoside. What does it mean? Free form means in the form of a glycon without being attached to any sugar. Or they are also sometimes available as glycoside, that is the glycon part attached with the sugar molecule. And so far about 10,000 flavonoids flavonoid derivatives have been reported, which represents the third largest group of natural products after alkaloids and terpenoids. If you look at the alkaloids, they represent the second largest group of natural compound, containing around 12,000 alkaloid derivatives, followed by following terpenoids, which contain around 30,000 compounds. Now the term flavonoids, it is basically came from the Latin word flavus, which means yellow. That means it is responsible for yellow color of different parts of the plant. Even though the term flavonoids means yellow, it is also responsible for contributing different other colors, okay, that are found in nature, and hence they are responsible for the colors of flowers, fruits, leaves, stems, etc. So before we discuss about the significance of flavonoids, mechanism of action of flavonoids, it is important to understand the basic chemistry of flavonoids so that you can understand the mechanism better. So this lecture mainly we will focus on the chemistry of flavonoids and the different way of classification of flavonoids with various examples of different classes. So coming to chemistry of flavonoids, they are mainly represented by 15 carbon atom basic skeleton. That means the basic skeleton of flavonoid structure contain 15 carbon, which are mainly arranged in the form of C6, C3, C6. That means the first 6 carbons, they are mainly arranged in aromatic ring, and the last 6 carbons, they are also arranged in aromatic ring, and both the aromatic rings are connected to each other with the help of another 3 carbon atoms, which may or may not be in cyclic form. Let us see. So what I said, the flavonoid structure consists of 2 aromatic rings designated as ring A and ring B that are linked to each other by 3 carbon atoms. And as I mentioned already, these 3 carbon atoms may or may not be in a ring form. they might be arranged in an aliphatic chain. Like for example, here you can see 2 OH chalcone, where you see the first ring containing 6 carbons, 1, 2, 3, 4, 5, 6, followed by 3 carbon, 1, 2, 3, which is connected to again another 6 carbon, 1, 2, 3, 4, 5, 6. So 6 carbon, 6 carbon and 3 carbon. So you see the 2 6 carbons are arranged in the form of aromatic ring, which are connected to each other by 3 carbons, which is in a aliphatic chain. Sometimes, even in fact most of the time, the 3 carbons may be arranged in such a way that it can give rise to a third ring, that is ring C, which could be either pentacyclic or hexacyclic in nature. Most of the time, the ring C represents pyran or pyron ring system. So you can see here the aromatic ring 6 followed by 3 carbon, 1, 2, 3. Here also you can see the 3 carbon, 1, 2, 3 carbons. Okay, so 6 carbon, 6 carbon connected to each other by a 3 carbon. But here in ring C, the 3 carbons are part of a hexacyclic ring. So before I proceed further, I would like to discuss a little bit about what is pyran and pyron ring system. It is known as, just count like this, 1, 2, 3, 4, 5, 6. It is known as 2H pyran. Similarly, this one is known as 4H pyran. So when the 2H pyran, it contains keto group here, it is known as 2-pyron. When the 4H pyran, it contains keto group at the 4th position, it is known as 4-pyron. Now, I would like to mention here that flavonoids mainly contain either 4H pyran or 4-pyron ring system. So when this ring C, either 4H pyran or 4-pyron is attached with the ring A, aromatic ring, it is known as either benzopyran or benzopyron. I would like to draw the structure of benzopyran and benzopyron here. So see from here, this is known as benzopyran ring. This is known as benzopyron ring. Benzopyron. So most of the flavonoids, they contain either benzopyran or benzopyron ring system. Okay, so we will see many examples where you will have better idea. Sometimes when the pyran ring system, it is saturated and the oxygen contains a positive charge, like this, it is known as pyrrhelium ion. Okay, so there is a particular class of flavonoid which also contain pyrrolium ion. Now we will go back to our slides again. So if you see this structure is known as flavon structure, where you don't have a double bond between carbon number 2 and 3. And in the pyrene ring system, benzopyrene ring system, the numbering is started from the ring oxygen, where it is given number 1 followed by 2, 3, 4, 5, 6, 7, 8. Okay, so when this benzopyrene ring system, it does not have a double bond between carbon 2 and 3 and contains a ring B attached to the second position, it is known as a flavon structure. Now coming to the classification of different types of flavonoids. Flavonoid can be classified based on either the position of the phenyl ring B, the degree of oxidation, or the saturation that is present in the heterocyclic ring C. So first of all, the classification based on the position of aromatic phenyl ring B to benzopyrene ring system. So if the phenyl ring B is present at the second position of the benzopyrene ring, it is known as flavon structure. Or all the flavonoids, generally the flavonoids earlier, they were, when it was discovered, they were the derivatives of this flavon structure. That's why this class of compounds are also known as flavonoids. So you have to remember, flavonoid not only means the derivatives of flavon structure, they also mean the derivative of other structure. We'll come back to that. So when the phenyl ring B is present at the second position of the ring, we call it as a 2-phenyl benzopyrene. Similarly, when the phenyl ring B is present at the third position, we call it as isoflavonoids or isoflavon structure. If you look at the structure, it is isoflavon structure, and all the derivatives that have this skeleton of isoflavon structure, we call them as isoflavonoids. Okay, and it is chemically known as 3-phenyl, because the phenyl ring present at the third position, 3-phenyl benzopyrene ring system. Similarly, when the benzene ring B present at the fourth position, we call it as neoflavonoids or neoflavon. This is the neoflavon structure. All the derivatives of neoflavons, we call it as neoflavonoids. Continuing with the classification, now look at the structure. The first structure, which is known as flavon structure, devoid of the double bond between the carbon number 2 and 3. Now when it contains a keto group at the fourth position, we call it as flavanone. Now if the flavanone structure contains a double bond between carbon 2 and 3, then it is known as flavone. Now you have to carefully notice the difference in naming. See the name of flavan and flavone. The difference between the name is, in case flavan, you use the word A. Here it is flavone, flavone. Okay, having the double bond between carbon 2 and 3 plus a keto group at the fourth position. So when you attach a hydroxyl group at the third position of the ring, it is known as flavanol. Okay, or flavanthriol. Similarly, when you attach a hydroxyl group at the third position of the flavanone, the ketone becomes flavanonol, and so on. When you attach a hydroxyl group at the third position of the flavone ring, it becomes flavonol. So look at the difference between flavanol and flavonol. The difference is just one letter. In flavanol, there is no keto group and there is no double bond between carbon number 2 and 3. Whereas in case of flavonol, there is a keto group and there is a double bond between the carbon number 2 and 3. Similarly, we call it as isoflavan, and when you have keto group at the fourth position, we call it as isoflavanone, and isoflavone when there is a double bond between carbon number 2 and 3. You see there is a similarity, there is a flow in the naming. Isoflavan, isoflavanone, isoflavone. All of them, whether it is flavan or isoflavan, okay, derivatives, you see the difference in the double bond. And then if it contains pyrrolium ion, as I mentioned in the board already, okay, then they are known as anthocyanidine. And if the ring oxygen does not contain a positive charge, but if the ring contains hydroxyl group both at position 3 and 4, they are known as flavon 3,4-diol, which are also known as leucoanthocyanidine. Now coming to the structures of neoflavonoids, two of the example, where the example, if you can see the ring B, which is attached to the fourth position in both the structure. The name of the first structure is 4-aryl coumarin, whereas the name of the second structure is 3,4-dihydro-4-aryl coumarin. Now we will go to the examples of different classes of flavonoid that we have discussed now. So first, the examples of the basic skeleton, that is flavone. Flavone means having a keto group at the fourth position and double bond between second and third carbon. Three of the most important examples, even though there are many derivatives of flavone, the most important examples are luteolin, epigenin and chrysin. If you look at all the basic skeleton of all the structure, all three of them, they have double bond between carbon 2 and 3, 2 and 3 and keto group at the fourth position. How they differ from each other? They are polyphenolic in nature. The first structure contains the 2-hydroxyl group at the ring B, whereas the second structure epigenin contains only one OH group, and the third structure does not contain any OH group. Other than that, all three of them have two OH group at the ring A, that is at the position 5 and 7 for all the three structures. Similarly, coming to the examples of flavonols, you see the basic skeleton of flavonol. The most important example, or you can say the most highly explored, the flavonoid example is quercetin, which is antioxidant in nature, and it is also found to be useful for the treatment of inflammation, cancer and various other disorders, which we will discuss later. So if you look at the three structures, there is quercetin, camphorol and gelangine. All three of them have the same basic skeleton of flavonols. Only difference between them, the presence of OH group at the ring B. The first one, quercetin, contains 2 OH group, camphorol contains 1 OH group, and gelangine does not contain any OH group. Next, coming to the examples of flavonones. Okay, the flavonones and flavones. The difference is the presence or absence of double bond. So flavonones, there is no double bond between carbon 2 and 3, whereas flavones, there is a double bond. Okay, so two of the most important examples, aspartame and naringenin. Aspartame, which is also known as vitamin P or permeability vitamin. Next, the examples of flavonols. The important example is taxifolene. Coming to the examples of some of the examples of isoflavones, which are again very important, the genistein and diazine. These two, you see, these two are the derivatives of isoflavone structure, where the ring B is attached to the third position of the benzopyrone ring system. And the difference between genistein and diazine, the number of hydroxyl group. In case of genistein, there are 2 hydroxyl group at position 5 and 7, whereas in case of diazine, it has only 1 hydroxyl group at ring A and 1 OH group at the ring B. Okay, and they are also known as phytoestrogen. Very important. Third one is pterocarpan. Pterocarpan, which is also known as phytoalexin, which are used as plant defense system, is one of the important chemical. Then some of the examples of flavon triols, catechin and epicatechin. Both are isomeric in nature. They are mainly available in green tea leaves. Then some of the examples of anthocyanidins. If you look at the ring system, which contains a pyrrolium ring, the oxygen has positive charge, and three of the most commonly used examples are cyanidine, delphinidine and malvidine. All three of them, you can see the ring oxygen has positive charge. The easy way to identify, the ring oxygen has positive charge. Now coming to some testing question. Can you answer me which of the following structure belong to flavonol group? Look at the structure carefully. Structure A, structure B, C, D. Structure A? No. The structure A is not flavonol. It does not have OH group at the third position first of all, and moreover this is the flavone group. This structure represents flavone. You see there is a double bond between carbon 2 and 3 and keto group at the fourth position. Structure B? No. Even though it has OH group at the third position, but it does not represent flavonol because it does not have the double bond between carbon 2 and 3. How about structure D? No, this is also not, because this represents a flavonol group. Why flavonol? Because there is no double bond first of all between carbon 2 and 3 and there is no keto group at the fourth position. The correct answer is structure C. You see, look at the structure, it's a derivative of flavone group. This is the structure A and having the OH group at the position 3. So the correct answer is C, which represents a flavonol group. Another question, which of the following represents an isoflavone structure? Look at this structure carefully. Isoflavone, remember isoflavone? Where the phenyl ring B is present at which position? The third position of the benzopyran or benzopyran ring. What's the correct answer? Structure A? No, it's wrong. Because you are counting from here. So you have to start counting from the ring oxygen. When you count from the ring oxygen, the position 3 is 1, 2, 3. So phenyl ring should present at this position. You just have to flip the structure. Flip the structure and start counting from the ring oxygen. So the correct answer is D. Yes, you count from here 1, 2, 3. So this is the structure of isoflavone. Isoflavone because again there is a double bond between the position 2 and 3. So with this I will finish my lecture here. We will continue again in the next lecture. Till then, bye. See you again.